Hey guys, in this video I'm going to be going through how to find the area under a curve. Now before I begin, there's one thing that I need you to be aware of. If you want to do well on this topic, you need to be comfortable with sketching various types of graphs and have a good understanding of how to integrate various types of functions. Because without these two main skills, it's going to become challenging for you to do well on this topic. So make sure you brush up on your graphing and integrating skills. Now whenever you're asked to find the area under a curve, it's always going to be between two endpoints or an interval. The first thing you want to take note of is whether the curve lies above or below the x-axis for the required interval. If the curve lies above the x-axis for the interval, like the example shown on the screen, all you need to do is integrate the function between the two endpoints, which we can write in general form as the area is going to equal the integral from the lower value, or the lower bound, which is a, to the upper bound, which is b, of the function f of x dx. We then evaluate this integral by hand or by using a calculator, depending on how hard the function is to integrate. Now, just as a side note, this is why you need to know how to sketch various functions, because by looking at the graph you can quickly see if the curve lies above or below the x-axis. To keep this video short, I'll do a couple examples of when the curve is above the x-axis. In my next video, I'll do some examples of how to find the area when the curve or part of the curve is below the x-axis for the given interval. Part A. We need to calculate the area of the shaded region. Notice that the curve y is equal to 3x squared is above the x-axis for the interval from -3 to -1. And so we can write the area as the integral from -3 to -1 of the function 3x squared dx. And because this is a simple function, we can integrate this by hand. And so evaluating this integral, this is going to be 3x cubed on 3 from -3 to -1, which is the same as x cubed from -3 to -1, since the 3's will cancel out. And so this is going to be -1 cubed minus -3 cubed. This is going to be -1 and then minus -27, which is going to be -1 plus 27, which is equal to 26. And because we're calculating the area, we finish this with writing square units. And so the area of the shaded region is 26 square units. Part B. We want the area of the shaded region for the interval from 1 to 4. Notice that the curve is above the x-axis for this interval, and so we can write the area is equal to the integral from 1 to 4 of the function e to the -2x dx. We can integrate this by hand, and so this is going to be -1/2 of e to the -2x from 1 to 4. And so evaluating this, this is going to be -1/2 times e to the -2 times 4, which is going to be -8, and then minus -1/2 e to the -2 times 1, which is just going to be -2. And so cleaning this up, this is going to be -1/2 e to the -8 plus 1/2 e to the -2. Cleaning this up more, we can take out half as a common factor, and we can write this as e to the -2 and then minus e to the -8, and then square units. Sketch the graph of f of x equals 1 plus x cubed and find the exact area of the region bounded by the curve and the axis. For this question, we haven't been given the graph of f of x, so it's a good idea to start with doing a quick sketch of the function. F of x is a positive cubic function translated 1 unit up, and so the graph is going to look something like this. We want the region bounded by the curve and the axis, which is going to be this region. The lower end point of this region is going to be the x-intercept of this function. To find the x-intercept, we let y is equal to 0 and then solve for x. And so using the calculator, we let the function equal 0 and then solve for x. The x-intercept is going to be -1. The upper end point is going to be the line x is equal to 0. And so notice again, the curve for this region is above the x-axis, which means we can write the area is equal to the integral from -1 to 0 of the function 1 plus x cubed dx. And using the calculator, we can work this out. And so the area of the bounded region is equal to 3/4 square units for this function. Find the exact area of the region bounded by the curve y equals 3x plus 2x to the power of -2, the lines x equals 2 and x equals 5 and the x-axis. Again, for this question we haven't been given the graph of the function, and it's not a function we've been taught how to sketch. So let's start by using the calculator to graph this function to see what it looks like. Looking at the graph, for the interval where x is equal to 2 and x is equal to 5, we can see that the graph of the function is above the x-axis. And so we can write the area is equal to the integral from 2 to 5 of the function 3x plus 2x to the power of -2 dx. Setting this up in the calculator, we can work this out. And so this is equal to 321/10 square units. Try some textbook questions to get a hang of how to find the area under a curve, and then log into the Maths Methods Club and start practicing answering exam-style questions related to this topic. To do this, log in and from the main topics, select Integration. And then from the subtopics, select Area under a graph. There are plenty of questions you can try. That's it for this video. If you found it helpful, comment below and let me know. Good luck, and I'll see you guys in the next video.